Good morning, everyone. This is Mrs. Kasayan, and one of the math teachers or Algebra 1 teachers in Clarksburg. So, today I'm going to talk about solving quadratic equations. Now, you have learned this before already in the past few weeks. So, this is basically a review or a recall of what you have learned. So, you can also go back to those videos or you can watch this video. All right, so remember, there are three ways to write a quadratic equation. So you have the standard form, which is y equals ax squared plus bx plus c. And then the vertex form, which is y equals a times x minus h squared plus k. And then you have the factored form, which is y equals a times x minus c times the quantity of x minus d. So if you remember, the h and k are the vertex. That's why it's easy. That's why it's called vertex form. And the factored form gives you the x-intercepts of the parabola, which is the graph of the equation. Now, there were also three different methods in solving quadratic equations that were presented to you in the past few weeks. So I'm just going to wrap up everything in one video. Now, what are these three different methods? You can solve a quadratic equation by factoring, by square root, or by quadratic formula. So we're going to recall each one of this. Now, the question is, when are we going to use factoring? When are we going to use square root? And when are we going to use quadratic formula? So, first, you are going to use factoring when the equation is in standard form and factorable, and it's easy to factor as well. And then, when are we going to use square root? When the equation is in vertex form. So, see this vertex form here? So, when you see squared, then that's a vertex form, which is in parentheses. And then, when are we going to use quadratic formula? Here's the thing. You can either use quadratic formula or factoring. It's all up to you. However, quadratic formula is specifically for equations that are in standard form. It could also be factorable or not factorable. So, you have the option to use quadratic formula when the equation is standard form. But specifically, if it's not factorable, then you have to use quadratic formula. Now, I'm going to give you an example. For example, you're given x squared minus 3x is equal to 10. Now, the first step that you're going to do is to set the equation equal to 0. Remember, we learned about zeros, x-intercepts. We mean that we're looking for the solution of the quadratic equation. So, then the first step is to set this equal to 0. So that would be subtract 10 on both sides, subtract 10 so that your right side is equal to 0. So now you have x squared minus 3x, so bring down minus 10 is equal to 0. And then you are going to recall your factoring, which is, we use this method. So the sum of negative 3 gives the product of negative 10. So what are these numbers? So when you multiply, is equal to negative 10, and when you add is negative 3. So you begin with the product of two numbers. So then you can say that 5 times 2 is equal to 10. However, because it's negative 10, I'm going to change one of these numbers as negative. And I'm going to be mindful that when I add, it will give me a negative 3. So just to review, so it could be negative 5 times 2, which is negative 10. And then negative 5 plus 2 is 3, negative 3. So the factors that I'm looking for are negative 5 and positive 2. Or you can switch 2 and negative 5, doesn't matter. So then you write down this left side into factored form, which is x minus 5 and x plus 2 is equal to 0. And then you have both of these factors are equal to 0. Therefore, I'm going to solve this as x minus 5 is 0 and x plus 2 is 0. Then this is your one-step equation. So add 5 on both sides. Therefore, x is equal to 5. Then subtract 2. Therefore, x is equal to negative 2. So those are the two values of x. You learned that. Now, vertex form. For example, you're given this problem. The quantity of x minus 5 squared minus 36 is equal to 0. So now I'm going to set this. So no, I'm going to isolate the variable x. Therefore, I'm going to add 36 on both sides. So now I have x minus 5 squared is equal to 0 plus 36 is 36. This becomes 0. And I'm going to isolate the variable x by getting the inverse of squared. So what's the inverse of squared? Is square root. Like the inverse of addition is subtraction, the inverse of multiplication is division, and vice versa. Therefore, I'm going to get the square root of both sides. So then squared undoes square root. Square root undoes squared. Therefore, what is left here is now x minus 5 is equal to the square root of 36. Could be two numbers. It's either positive 6 or negative 6. Why? Because positive 6 times positive 6 is 36. Negative 6 times negative 6 is also positive 36. That's why you have plus minus 6 here. And then you're going to solve them separately. Then you have x minus 5 is equal to positive 6, and the other one would be x minus 5 is equal to negative 6. And then you add 5, that's your one-step equation there. Therefore, x is equal to 11. And then the other one would be plus 5, therefore x is equal to negative 1. All right, so those are two values of your x by using vertex form. And then you use the quadratic formula. Remember, the quadratic formula gives you have to know your a, b, and c from the standard form. So for example, you're given this for problem. So when you look at this problem, it's already set equal to 0, so you don't need to rewrite it. And then you identify what are the factors. So if you can do factoring first. But this one, what are the factors of negative 5 that gives you negative 3? So the sum of negative 3, product of negative 5, which is impossible. Why? Because there are only two factors of 5, 5 times 1, or negative 5 times 1. So when you add this, it's 6. When you subtract, it's 4. When you 1 is negative. So in other words, there's no way that I can find negative 3 as a sum. Then first step is to use the quadratic formulas to identify your a, b, and c, which are the coefficients of your left side. So a is 1, b is negative 3, and c is negative 5. And then you just plug it into the formula, and that gives you x is equal to a negative. The formula says negative, and then my b is also negative. So I'm going to put this inside the parenthesis, plus minus. And then don't forget to put it inside the parenthesis when you square this, especially when you're using your calculator. And it's going to mess up your answer. So 4 times a, your a is 1, and then your c is negative 5. Okay. And then 2 times 1 because your a is 1. All right. Now we're going to simplify the sign. So negative and negative gives you what? Negative times negative. So this gives me positive. So that's why number here will only be positive 3. Plus minus. Now a negative 3 times a negative 3 should be positive 9. Now I need you to point this out. When there is a minus and a negative, that gives me positive. Okay? So 4 times 1 times 5 would be 20. Over 2 times 1 is 2. Therefore, x would be 3 plus minus 9 plus 20 would be 29 over 2. Now, do I need to solve for the square root of 29? You don't have to, but if you want to, you can also do that. However, I'm just going to leave it in a radical sign since it's not a perfect square. So 3 plus the square root of 29 over 2. So that's one of the answer because it's plus. The other answer would be 3 minus the square root of 29 over 2. Now, if you want to make it more fancy, you can also x sub 1, x sub 2, just so you have two different answers. You can also do the other ones, but not necessarily. So you have this as your solution. All right, so and that's it.